Okay, so now that we've covered most of organic, let's take a look at some old diploma questions, starting with the first one where you need to be able to identify compounds that are inorganic. So the first few are fine. D sticks out right away to me because I'm seeing that Cn negative, and that's one of those ions you need to look out for that are going to be inorganic. In question number 2, we want to be able to draw that structural diagram, and I like just to emphasize that whatever's in brackets are going to be a branch. So I like to draw it out, so I would have 3 carbons on my main chain, so I like to draw it and then compare to see what I have, and then 2 methyl groups on carbon 2, right, because there's 2 of them in brackets. And then we know that the end ones are CH3, so we can add that. And when we take a look, we see that drawing is going to be B. Looking at your next one, we have a compound we need to name. So we need to identify our longest chain. And I'm going to start on the left. And because all these carbons would give me the same number, it doesn't matter which one I start at. So say I started just in a straight line, and that would be carbon 1. We have 2, 3, 4, 5, 6, and 7. And I named or numbered from left to right to give my first smallest one on carbon 2. If I went from right to left, I wouldn't see one until carbon 3. So I go left to right because that gives me that smaller number first. So this is a methyl group, methyl group, methyl group. So we would need that multiplier tri. And your longest chain was 7. So this is 2,2,5 trimethylheptane, and it is definitely trying to throw you off with these hexane ones that we could rule out right away, and you would pick that if we maybe identified the wrong chain. Our next one, 2,2,4 trimethylpentane. So if it's pentane as our root, that means there's 5 carbons in the longest chain. So taking a look at A, we have 1, 2, 3, 4, 5. So it could be that. The next couple, 1, 2, 3, 4, 5, 6, not going to be B. 1, 2, 3, 4, 5, 6, not going to be C. 1, 2, 3, 4, 5. It could be D. So now we've numbered our carbons here, and based on what I have, I'm going to change my numbering. So I'm numbering from right to left. So 1, 2, 3, 4, 5. And then that would show me on carbon 2, I have 2 methyl groups, and on carbon 4, I have a methyl group. So it looks like our answer is A. And if I tried just to look at D, 1, 2, 3, I'm seeing my side groups on carbon 2 and on carbon 3, but I needed one on carbon 4. So I can rule that one out. Moving on to our next question, it's asking which of the rows identify the structure with the correct name, and we want it to have the formula C8H16. So looking at your first example, we have a benzene ring, so we know that's 6 carbons, and then you have 7, 8. So we have 8 carbons, so that's good. 8. Now we would need to look at the hydrogens. So with that benzene ring, each one of these, sorry, not this one. Oh no, that one too. Each one of those would have a hydrogen, so that would be 6. And then you have 7, 8, 9, 10, 11. So it's not going to be this first one. Let's try the second one. So we have 1, 2, 3, 4, 5, 6, 7, 8. So you have the C8, H. This time you have 2 here, 2 here, 2 here, 2 here, 2 here, 1 here. So we can add those. So 2, 4, 6, 8, 10, 11, 12, 13, 14, 15, 16. So this looks like it's a possibility. And now let's just check the name. This is hexane because you have 6. It is cyclo because you definitely have a ring. And this is an ethyl group. So it looks like our answer is B. So let's just take one quick moment to check the rest. And just going through it one more time, I'm just adding in my hydrogens and counting. So 3, 4, 5, 6. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is a possibility. And then looking at it though, the cyclo is in the wrong spot. So it's not possibility. And then that last one, doing the same thing, again, it looks closer. This time it's saying propyl cyclopentene. Ending in E means there should have been a double bond somewhere within that molecule, but there's not. So we know we're right with B. Our next one, we have some information about a bromine test. So it tells us bromine is added to an isomer C6H12. There is no light, and then they are looking that the color of the bromine solution changed from orange to colorless, meaning the color disappeared, right? It's staying clear. So if that happens, we are able to determine whether we have a alkene or an alkane. So just taking a look at what we have, I'm just going back over here. If you're adding it in and that color disappears, that means you're breaking a double bond. The bromine is going onto the molecule, so you're not going to see any bromine color. So you must have an alkene. So we're looking for a hydrocarbon that ends in ENE. So we can take away the two that said, and if you're ending in ENE, you are going to be unsaturated. So this is showing that we know the bromine test. It is also showing we know the term saturated and unsaturated. I believe we did one similar like this in a different video, but let's do it one more time. So looking at our compound given, we want to name some or be able to describe it based on this information. So the first part, if you have benzene, you're aromatic. So it's going to be A or B. We can rule out the last two. We do have a hydroxyl group. We see that here. You also have an ester. So we're ruling out the top one. And the last one, we have an ester. So this was going to be B, just showing that we know all the different types of organic compounds. The next one is bringing that term isomers in once more. Isomers means you break down to the same chemical empirical formula. So looking at that first one, you're figuring out exactly how many of everything you have. So you have 3 carbons, and all of these, or the first two have 3. The second one has only 2, and the last one has 2. So 1 and 2 could be isomers, 3 and 4 could be isomers so far. Now let's move on to hydrogens. So with our hydrogens, we have 3 here, 4, 5, and then 6. We don't have to interpret any because it's not a line diagram. On number 2, we have 3, 4, 5, 6, 7, 8. So it looks like 1 and 2 are not isomers, even though each of these have 2 oxygens. Looking at 3, you have 4 hydrogens and 2 oxygens. And looking at 4, you have 4 hydrogens and 2 oxygens. So these are going to be isomers of each other because they're exactly the same, and 1 and 2 are not because of the difference in hydrogens. So we're looking for the answer to say 3 and 4, which is D. So we have another naming one. This time we want an isomer of C6H12, and then knowing it's named correctly. So if it is named correctly, so I'm just taking a look quickly. Already I can rule out B because I see a double bond, but the name has ANE. I can also rule out C because we see a double bond, but the ending is YNE, which implies a triple bond. So this first one, the name is correct, that it's methyl cyclopentane. Now let's see if it follows that. So you do have 5 carbons in the ring, plus that 1 on the side group. So that would be C6. Then we'd have 1 carbon here and 2 on the rest. So 2, 4, 6, 8, 9, 10, 11, 12. So it looks like our answer is A, but I always just like to double check the last one just in case. So the last one we have 1, 2, 3, 4, 5, 6. It's C6. And then H, 3, 4, 5, 6, 7, 8, 9, 10. Not enough. So we're pretty confident that our answer was A. Looking at 10, which of the following condensed structures represent the compound with the lowest boiling point? So here you have all these compounds that are all part of the same family. They're part of a homogeneous series. This first one has 2 carbons. This second one has 4. 2, 3, 4, 5, 6. This one has 6. 6, 7, 8. This last one has 8. Because it's asking for the lowest boiling point and they're all part of the same group, alkanes, you're just looking for the smallest molecule. So that would be A. If it asks you for the largest boiling point, you're looking for the biggest molecule. If they compared the boiling point and gave you some alkenes and alkynes, we would have to have an understanding of how that would rate as well. So similar to a question we've done before, just recognizing this, and this picture does come up quite often, and this is just fractional distillation. So it's when you have crude oil or a mixture of hydrocarbons and you heat them up. When you're heating them up, the smaller ones will come up first, then medium size will come out in the middle, and then your large molecules will come out last, and they are separated by boiling points. So even though this question looks familiar, they can ask very similar questions, but in the same way. You're separating hydrocarbons by their boiling point. The smaller molecules will boil first and come out the top, larger last. Okay, our number 12 is starting to get into reactions. So we know that esters are formed from an alcohol and the carboxylic acid. When you are naming, and we can write this out, but the methyl group or the part from the alcohol gets written first, and then the part from the carboxylic acid gets written second, and you write out you change its name to O8. So if we understand esters reactions, to form this, water leaves and the rest link together. So methanol and ethanoic acid get close enough that there's an OH close enough to an H to leave as water. Then whatever the OH was bonded to and whatever the hydrogen was bonded to, which would have been an oxygen, come together and bond to each other. So you're always going to have those two products. So here we have methyl ethanoate and water. Okay, moving on, this type of reaction occurs when ethane gas and chlorine gas react, and the name of the compound is. So this one gets a little bit confusing, but because you have ethene gas, you are breaking a double bond. If you're breaking a double bond, that is going to be addition, not substitution. And if you break a double bond, that means two of your carbons can bond to something else. So this one is implying just one, so it has to be A. And moving on to number 14, starting to take a look at isomers. I don't know why I said that. Polymers. And it's asking how, which of the following monomers was required to form what was in the diagram. Now, polymers are formed from a series of addition or condensation reactions. So because you don't have OH and H's in here to come together to form water, it's going to be an addition reaction. So you want to figure out which one of these looks most like the one we see up here, but with a double bond. So if I start writing the first one out, I have CH2. So there's two hydrogens on this one, Cl, and then another carbon, another hydrogen, two hydrogens, and another chlorine. Okay, so it can't be this one because we don't have any double bond to break. So let's try the next one where you have CH3 attached to a carbon, single bonded to two hydrogens, and a Cl group. Can't be that one for the same reason. We need that double bond to break. Let's look at C. You have carbon attached to two hydrogens, attached to a carbon, which has one hydrogen, and a chlorine. So this one has a double bond that can be broken. So this is a possibility. So let's check the last one where you have carbon with one hydrogen and it's attached to another carbon with a chlorine. So this would imply we have a triple bond between them. And to repeat this molecule, you won't have enough hydrogens. So this has to be C. Okay, moving on from here. Hopefully right away you recognize this reaction as combustion. And bringing in some thermo, any combustion reaction will release energy to the surroundings. So it's going to be A. So combustion reactions do not absorb, they release. Looking at our question number 16, you have all these different molecules, and then it's asking the structure diagram that the student drew can be described as. Oh, I think I'm missing something with this. That's okay. So I think this was a two-part question, and then we're just seeing one part of it. So if I'm looking at the first one, it is definitely not aromatic because I don't have if I'm just looking at that first one, I don't have a benzene ring. B, aliphatic alkene. Nope, I don't have any double bonds. C, alkane containing a double bonded 4-carbon ring structure. No double bonds. An alkane containing a 4-carbon parent with only single bonds. That looks like our best answer is going to be D. And as mentioned, this rest here was probably because there's another part to this question. Number 17, the organic compound that contains branches off the parent chain. Definitely this one would be a branch. Number 2 would not be because bromine is right on there. It's not attached to anything else. Methyl would be because that is a branch. Ethyl would be. Cyclo would not. And butanol has nothing attached. So your answer here looks like it's just 1, 3, and 4. It is very common for students to pick number 2 because if you take a look at pentene and you added your bromine, it is right on the carbon just like hydrogen would be. So that is not considered a branch because hydrogens are not considered a branch. So you need an actual chain like CH3. So something that is branching off and having other atoms attached to it. Okay. So moving on back to another polymer question. We have this compound, we have some information about it, and then we see that it is going to be involved in a reaction where we have a repeating link. We know that because of the N. So this would be the monomer, and we're forming the polymer. So completing the information, preparation, when it's actually prepared, it is a polymer. And the reactant molecule used to form contains, this would be a carboxylic acid. So your answer was C. This next one looks pretty intense, but it's just asking you for the molecular formula. So how much of carbons, hydrogens, nitrogens, and oxygens do we have? So it doesn't really help us with nitrogen and oxygen because we're looking at your distractors. They're all the same. So we just really need to figure out carbon and hydrogen. So with carbons, you have 1 here, 1 here, 1 here. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So figured it would be C18 because it's weird that they would just have 1 at 17. And now let's count our hydrogens. So you'd have 3 up here, 3 over here, 1 here, 1 here, 1 here. This is a 1, you just can't tell. You'd have 2 here, 2, 2, 2, none here. 1's here, 2 would be here, none here, 1 here, 1, 2, 3, 4, none here. You'd have 3 here, there's 1 here, 1 here, and 1 here. So once we've counted how many we have, let's go ahead and see what our total is. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. What am I missing? There must be one more. So let's try one more time. 3 from this one, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oh, none here. 22, 23, 24, 25, 26, 27. So the answer is C. So my mistake was over here, but this carbon has the 4 lines coming from it, so it would not be attached to any other hydrogen. Okay, number 20, which of the above show isomers? So isomers is coming up a lot in this test, so just make sure you understand that they just have the same amount of everything within. So number 1, you have 1, 2, 3, 4, 5, 6, so C6. Number 3, 1, 2, 3, 4, 5, 6, so C6. Number 2 is a C6, and number 4, 1, 2, 3, 4, 5, 6 is also a C6. So that's not narrowing anything down for us. So let's try our hydrogens. So from number 1, we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. From number 2, we have 3, 4, 5, 6, none here, 7, 8, 9, 10, 11, 12. From compound 2, we have 2, 4, 6, 8, 10, 12. And from compound 3, 1, 2, 3, we have 1 here, and 2 everywhere else. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what the ones that are isomers have the exact same molecular formula. So that is 2 and 3. So just remember, even in a line diagram, the amount of hydrogens you have, so this N one that has a carbon only has 1 line going out, and we need 4. So that's why I can fit 3 hydrogens. This carbon here has 3 lines, and we need 4. So it can fit 1 hydrogen. So you just go and see how many are missing, and that's how many we can fit. All right, this next one, just being able to describe some vitamin C. It's definitely a ring. There is no benzene, so it's not aromatic. You must have benzene. And then what it contains, it definitely has some hydroxyl groups. And it looks like our other one, so I'm just looking between these two. To be an ester, you need carbon double bonded to an oxygen, single bonded to another oxygen, and then a chain. And it looks like we have that here. Carbon double bonded to an oxygen, single bonded to an oxygen, going off to another chain. So I'm going to say that answer is A, and we don't have any carboxylic acid. Okay, this one I know, actually, I give this on one of my tests, and students really struggle with it. And the way I try and describe it is take a look at your distractors, see what you can draw out, and essentially like push it together. So it doesn't make total sense, but that is how we can form what we have. So to start off with, if you had ethane, it would just be a straight line. If you had hexane, it would be 1, 2, 3, 4, 5, 6. But there's no branches, no matter where you put this on the molecule, you're not going to make that same structure. So it's not A. Propane, 1, 2, 3. That's too many, sorry. Propane would be 1, 2, 3. And then on pentane, 5, 1, 2, 3, 4, 5. Same idea. I want to go place this somewhere. I'll try over here, but it's not going to be the same thing. So it's not B. Try that propane again with 2,2-dimethyl propane, which would be this. And if it's dimethyl, you would have that. We are getting somewhere here. So we can take this end and attach it here. But we are missing this last part. So let's try the last one with a methyl propane, which would look like that. And then that same structure, which if we push this together and connect, we now see what we need. So it looks like the answer is D. Okay, moving on from here. Another one with a polymer. So asking which monomer was used to make this. Again, we're not seeing water, so it has to be a series of addition reactions. So you need a double bond, and they're all very similar, but because of, like, it's not going to be D because you need to see hydrogens. I would double check the glass too and see what one we have more of. So it looks like you have more hydrogens in comparison to chlorine. So that would make sense if it was A, right? If you chose B, we'd have the same amount of hydrogens and chlorine. And if we chose C, we'd have more chlorine than hydrogen. Okay, so moving on from here, again, another question, identifying organic. Carbon dioxides. Dioxides are inorganic, so not 1. It's going to be 2. This ion is not organic, so not 3. It could be 4. No metals, so not 5. And the CN is coming up again, not 6. Oh, I said not 5 and wrote it down. And so the rest would be 6 and 7. So 2, 4, 6, 7. Looking at some structures, being able to say what we have. So looking at that first one, to identify a carboxylic acid, that would be number 2. Aromatic, you need a benzene ring, that would be number 6. An alcohol is number 1, and an ester is number 5. So this is just knowing your functional groups. And if it asked you about an alkene, Y-N-E, we would have said number 4. If you asked about an alkene, E-N-E, I'm sorry, this is an alkyne, E-N-E would be number 3, and so on. So we just want to know all of those functional groups. Number 26, being able to predict. So number 1, because if we drew this out, this would be an alkene, adding in a reactant. Because you only have one product, you know a double bond was broken, that has to be addition. That's number 1. Number 2, you're starting with one product and getting out 2. If we drew that out, so C with all those hydrogens. Okay, we've talked about how when hydrogen and OH get close together, they want to leave as water. And then the rest, this carbon and this carbon, because this is gone, now need something to bond to, so they bond to each other. So that's another way you can figure out elimination reactions, because you start with one reactant and you get 2 products. So elimination would be number 2. Substitution, we can see from what our products, we have an alkane, you're adding in Br2. We have a hydrogen swapping places with a bromine. If it's swapping, that's like substituting, so substitution. And then even though I think esterification is one of the harder ones to deal with, I also think it's an easier one to recognize. So if you have that COOH with OH, COOH is your carboxylic acid, OH would be your alcohol. Whenever those two come together, you form an ester and water. So that would be our esterification. Number 27, so we're getting towards the end of this package. Number 27 is asking us to react. So here answers can vary depending on what we're doing. So I'm going to look at my products to help me. And because I started with chlorine gas and on the right hand side I see HCl, this implies to me that we had substitution. So I started with a single bonds. So I'm going to say my first one with ethane, and then this type of reaction is substitution. In method 2, I'm adding in HCl to a hydrocarbon, and I'm only getting out one product. So that tells me I'm breaking a double bond and I'm adding my smaller molecule to the bigger molecule. So that would be addition. And with that one, I could go between these two, but because it's not saying excess or anything like that, I'm going to pick number 2. And I also know it's not ethine, because if I did have that, I would end up with another double bond here, which I don't have. And just as we talked about, that would be breaking of a double bond, which is addition. So I did say that there would be number of answers here, but there's actually not. It's 1, 8, 2, 5. Sometimes a question could let you choose your own and you just have to make it correct. That's what I thought this was going to be, but it was a little bit easier, even though it looks confusing. Okay, so looking at our number 29, we have hep2-ene. So we have double bonds and but2-ene. So we want to number what applies to both. So because we have double bonds, you are unsaturated, so you can rule out number 1. You don't see the word cyclo, so you're not cyclic. You don't see a benzene ring, so you're not aromatic, which would make you just alphalic. You are not an alkane. You're an alkene because there's double bonds, and same reason for the last two. Not 8, but you are 9. So saying it contains single bonds, so even though you have one double bond between 2 and 3 on each of these, the rest would be single bonds. So here we had 2, 4, 7, and 9. Okay, here's the second part to that question that we saw. So I thought there would be another part. So here, looking at the 8 carbon structures numbered above that are isomers. I think I will skip over this one because we've done lots of isomers. So essentially we know count how many carbons you have, count how many hydrogens you have, and find the ones that would be the same. Okay, 31, also a bit repetitive, but we can do one more. So what are organic? So definitely number 1, definitely number 2, number 3, not number 4 because of that metal and that CN. It would be number 5, not number 6 or 7, because of the metal, also because of the CO3 -2 ion and the carbide. So this one was 1, 2, 3, and 5. As always, I hope this helped. If you did find it helpful, please subscribe and like. And if there's anything else you'd like me to do, just leave me a comment. Thanks for watching.